Welcome to Developers Meeting on Sunday, the 18th of June, 2023. And let's start. Ido, I give the word to you.
Yeah, thank you. Yeah, so this week was good. We want to get some pictures and videos from the Allsky Camera, and we had Joe kind of hack something really quickly and put the camera out. He suffered later on this week, like his camera suffered from dew, and he kind of hacked something that is outside of the design of Sky 360. So I think it's important for us to discuss what is the design of Sky 360, are we going to eliminate dew, and what's our plan there. So Richard, back to you, I guess.
Yeah, okay. Quickly about condensation and to put things out there. Of course, there's always condensation if you have a cold side and a hot side, and you have humidity in the hot air, on the hot air side, and this will always condensate on a cold plate. We all know this. The easy solution for this is ventilation. So that's why you need a compartment that has a certain volume, so that the airflow can happen. If you make a compartment that's too tight and has no ventilation, then things happen like Joe happened. To Joe happened. So what I can show you quickly is, the airflow concept. Hold on a second. Here it is. So I share my screen quickly. Okay, what you here see now, it's just a picture. It's not the 3D. I cannot turn it. This is the enclosure with the fisheye camera on the left, the PSU, which is the yellow intake, and then we have some extra fans. These three elements create an airflow, and what you see, the green is, let's say, the airspeed that happens on certain places. So the thicker it is, the greener it becomes, the higher the velocity. But what it also
we don't
shows
see
us,
green.
You don't see green?
Nope.
What color do you see here?
I only see the yellow and blue. So I see the arrows, and I see. Yeah.
You see the yellow and blue. Okay, hold on a second. I start sharing again. Let's do it on this screen. Do you see now better? Is it now green?
Nope. Same.
So, what do you say that's green? What you're saying that's green? We can see the yellow, the blue.
No,
I see green.
Oh,
I
the
see
background. Green. Okay, I thought it's
the
station. Okay, got it.
Yeah.
Okay.
And you don't see this the enclosure, of course. The enclosure is transparent at the moment because we only see the airflow.
So this is. Yeah, I assume it's like a blurry picture.
Yeah,
I don't understand. That's the okay.
It's blurry.
My apologies.
It's just the airflow, what you see here.
Yeah,
right?
So that's the
no
airflow
structure.
simulation.
Yeah,
okay.
Exactly. Yeah.
Yeah.
And what's important is that we get airflow up here into the dome. Okay? Here we need airflow. Mm-hmm. And that's something that we need to redirect the airflow coming off from the camera directly into the dome via one of these openings. So what we will do is just add a little vent duct to the side, to one side of the camera's ventilation system, so that the air from the camera blows into the dome and then goes out again. Okay, that's the only trick here to make this. And what we can then do is, if that's not enough, we can then add another ventilator here, which is directly the surface between the top of the enclosure and the camera tower. So there's an opening that's still not used at the moment, 5 centimeters. We can add a fan there to increase ventilation at that particular area here for the Allsky Cam.
Yeah, and I guess the recommendation to Joe specifically will be to move to our like to use the full enclosure and to put the camera on top of it and start testing the ventilation solution.
So first of all, he has an enclosure. He already has
Yeah,
one.
yeah, yeah, I know.
He can put it outside and put it in.
Yeah.
Why he did it temporarily, I don't know. But I would suggest to him, if he sees that, Joe, try to use our enclosure, because there's a reason why we choose that design. And very much important is that the smaller your compartment is, okay, it's nicer to have it as small as possible. I understand that. But the problem is the smaller the thing becomes, the more indifferent the airflow will become. If you have bigger compartments, your airflow will be much more distinct, and you can control that. So, and basically what he did not do is to use any fan. So he's now building it, rebuilding it, I think, and adding some fan to it.
Good.
Okay.
Nice. Let's move to you, Fabio. Any?
Yeah, sure. Just a second. Coming back here. Okay, so I have a couple of updates. First of all, I'm moving most of the ROS2 nodes from Python to C++ and also onto a different repository. Okay, I'm creating this Sky360 ROS2 repository. So instead of using the simple tracker names and things like this, I'm using our Sky360 with the topics. And so I'm renaming some of the topics and converting all the Python code to C++. So far, I converted the camera node. It's working, and the camera, the background subtractor, and the blob detection, also the frame provider, they all converted and working. But
wow.
They are not getting any kind of configuration so far, or any kind of configuration or parameters. They are not changing. It's all fixed there. I just did it. I'm just doing with the fixed parameters for me to test everything working, and then I will start to make it configurable. So the camera will start receiving parameters, and then the other nodes also will be able to change the parameters as configurable. So right now they are just fixed and doing something just for me to test all the entire pipeline. Okay. So right now I'm working on the tracking on the track provider node, and that's the most complex one, and that's the most CPU intensive one, and that I think that's the one that will benefit the most from converting to C++. Mm-hmm. So that's the one I'm working right now. In fact, I'm doing that right now, and I'm getting some errors, but that's normal. So I'm converting because that's a lot of code, a lot of classes, and so I'm converting and testing and doing everything. And as soon as I have the frame, then I'll go to the other nodes, the ones that are still missing, and then for the last, I'll be doing the annotated frame provider. But so far, I think I'll just get the annotated frame provider, put the Python one inside our current repository for me to test everything, and then later I will convert to the annotated frame provider also, because it's also a little bit CPU intensive. But that's my plan for so far. It's coming along, but it's taking a little bit more effort than I thought it would be. That's fine. But it's coming along.
Nice.
And
I saw you posted some of the RQT kind of outputs.
Oh yeah, because I'm generating all the topics and
nodes.
And nodes, so I can look at the whole flow, of the.
Yeah, is it something you can demo right now, or?
I might, because right now it's not. Right now it's in a mixed state, but I have it open here. It's not compiling right now. It's compiling, but it's not running.
Yeah, got it.
So because I'm working on the tracking, I can disable the tracker node and try to, but it will take us some time. I might do it later on, and then I would have to just comment some stuff here and then try to do it, and I can try to demo it later.
Okay, no problem.
And also one of the things that happened during this week was we started testing the camera outside with the Aussie. He had the problem with Dew, but it was not with this problem that we're talking about. It's about the camera settings. And we saw that with our current settings, and it will be a challenge for us to have any tracking at night that is above something that we will have to still figure out if it will be able to see to be able to get any sort of decent frames per second with trying to get stars on the camera.
You're speaking because of the low frame per second, right?
Yes, true. So we have to increase the exposure a lot, and if we had to increase exposure to 1 second, 2 seconds, 5 seconds, then you have one frame each 5 seconds, and that's that's it will be trackable. You will just see a trail on the screen.
Again, the sensor won't be providing tracking data, but it's not going to be the only sensor that we will have.
No,
because
true.
we will have also like passive. We will have passive radar also.
No, that's true, but not for now. It's just for everyone to also adjust expectations. Because I was expecting to see at least something with, I don't know, 200 milliseconds or something, but it seems that it's not possible. Not with our current setup, because I never tried an astronomic sensor with a fisheye lens. And also, on top of the fisheye lens, we still have the dome, and the dome takes a lot of the light from the fisheye lens also. Even though it's transparent, it takes a lot of the light. That's why we're trying to reach for the best f-stop that we can, but anyway, the domes takes a little bit of the light, so I don't know where we can increase that or how or what will be the best parameters for us to use at night. That's something that we will have to investigate further. That's it.
Yes. Yes.
I was not expecting to have such low frame rate. If that's what it is, then that's what it is. There's no, we cannot run from that right now.
Yeah.
May I
see Christian. I see Christian join, but go ahead and ask. Maybe then we'll get Christian output also.
Yes, maybe Christian can answer this. So my question is, the auto exposure as it is now that David developed with you, is it calculating on the whole view or just, let's say, the inner core?
No, it's sort of. It depends. Okay, so we are adjusting that, but for daytime it doesn't matter. It's working perfectly. Yeah. For nighttime it also it will not matter because it will be mostly black, and so we will be calculating on the frame. Even if we can get a part of the center, that would be maybe better, and that's what we're trying to aim right now.
Yeah.
But that's not the whole issue. Okay, the issue was that we set some thresholds and also some max parameters like exposure. We limited the exposure and also limited the gain. And even limiting the exposure for the one that we set for to 50 milliseconds, so it's not enough. We have to see what we need to set to have a decent image for the night sky, and to set the max. So then when we reach that exposure, then we set to start to increase the gain. So far it's too low. I will be adjusting. Me and David will be adjusting that during this week. As soon as I have access to the Aussie Orange Pi, so I can play with parameters there. Then we can try to set a maximum exposure that's reasonable. But that's it, and so the auto exposure algorithm will work better at night. So right now it's just black. It doesn't work very well in the night sky. it works perfectly here in my apartment with the lights turned off, but the night sky is completely different. And since I didn't have access to the night sky, no one did, in fact. I live in the middle of the city in an apartment, so it's impossible for me to get something outside. So right now we're encountering the real challenge, and that's when we arrive with the better parameters for the night sky, for the night part of the auto exposure algorithm.
Mm-hmm. So would it be an issue if we, let's say, go to a 10 frames per second frame rate at night, whereas we have, let's say, 20 on
that's
the
issue. I don't think we will be able to get 10 frames per second at night. I think we'll be getting 1 frame per second or even less to get a night sky view with that we can track, like the ESS and things like this. So that's my issue right now, and I will try to do my best so we can get a better image, but that's it.
Can I ask a question? I'm actually new here. If that's okay.
Go ahead.
Okay.
Yeah,
sure.
my name's Mason. Hello. Yeah. So I just had a question. So you're talking about some of the exposure limits. Do you have a specific standard for what you're using for that? Like, I mean, what exposure level is good enough? I mean, I saw some documentation about tracking the ISS. Is that kind of standard for how you're saying, like, well, this is a bright enough object that we can detect just enough?
Yes.
Okay.
Exactly.
Okay,
yeah, we are designing that ISS is kind of the target for the station.
Okay. So then, thank you. So then, the frame rate limitations you're coming up against, are those, software limitations, hardware? Again, I'm new here. I don't understand all the current roadblocks, but what exactly are those?
So the limitation right now that we are experiencing, it's actually the exposure limitation to get a proper picture at night. Okay. Which means that we need to go to a multi-second exposure in order for us to get like in dark places like starlight, right? Like
and then features wind up streaking. I guess you're producing streaks rather than individual images. I guess if you have too long of an exposure.
Exactly.
Yeah.
Okay.
Exactly. Yeah, that's true. Yeah, that's the whole point right now. So since we didn't have any kind of night exposure before, right now we were start to play with that, and then we arrive to the better parameters to get to have the maximum frames per second at night. But right now we don't know the limit.
Okay, interesting. All right, thank you. Yeah.
Just to make it clear, we try to design a station that is multipliable over the planet, so that anyone has access to the hardware in a reasonable way. So not too expensive hardware. Of course, in the night we want to have 2-inch sensors to collect more light, but 2-inch sensors are incredibly expensive, and we wouldn't get anywhere if we start with very expensive equipment, because people would not just be able to procure that.
That makes sense. Yeah.
And let's
say something that's cheap and easily deployable.
Yeah, it's a compromise. So we choose this camera as a compromise where we say, okay, it costs 800 already, but it has cooling and it's professional for astronomy and so forth. But yes, it's a 1-inch sensor, and it does not collect that much light as we want it to.
And I have Christian is here also. He can also help me on these. I have some ideas. Okay, so we can get better light on the sensor. We can increase the beam, but that will cut our resolution in half. But we will have 4 times the amount of lights, because you get 4 pixels for each pixel that we have. We can increase the beam. That increase a little bit, but we'll cut the resolution half for the nighttime.
Go ahead. Sorry.
Okay, sorry. And also what I can do is, since I know that's nighttime and I know that what we're targeting for, I can also, like, since the frame rate will not be a limitation here for us, we can do 16 bits, and I can do an auto stretching for the first part of the histogram, so I can increase a lot of the things that are not very bright. I can make it much brighter, and that are some of the ideas that I have. Go ahead.
I'd like to adjust the contrast basically to get
So there is more into that, and this is I would add it's kind of a work that we started, but then we stopped because we want to make the station operational, and this is kind of an improvement that we can do, and that's like the custom firmware, right? Because in the end of the day, we are treating the sensors as sensors, and right now we are treating as a retrieval of image. And what we are really interested in is the counts of the photons that we receive from the sensor. That's what's important for us. Wait. And more than that, in the custom firmware, we're able to create a small portion that will only provide us anomalies. So we will improve so think about it like the way compression works, right? When you have like a single frame that comes every, let's say, 3 seconds, and then you get only the changes, right? That can improve like by magnitude, and we can also like, as you said, change the resolution and all of that within the firmware itself to just like try to get more light or more understanding. Again, because the moment you have light and it's dark, you're going to affect more pixels, and more pixels you don't need the highest resolution. Right, but again, we need to test that, and most likely these night edge cases, I would say we need to push it to the custom firmware, because that's where you will get more, output than anything.
Right.
Okay, I have some. I don't say questions, but just some remarks on these, because the firmware itself doesn't do much. It's just code. You have to see what CPU, what the camera has, if it's fast enough to provide and to do some other algorithms besides just copying the image for the USB. I don't know that. I would like to, but I tried to search it, but I didn't find it. What kind of CPU it and the amount of computation it's able to process. And also, what we can do, it's not only on the firmware, because right now I'm just getting the raw image from the camera itself. I can get the raw image, and I can process the raw image as it is. So, and I can change the bin, I can change everything. It doesn't depend on it's not dependable only on the firmware to do that. I can do that directly with the SDK. Okay. But other than that, I don't really like the SDK that much, and I was looking maybe in the future to, but we'll have to do that. If you write a custom firmware, we have to write the drivers also. So anyway,
well, the driver itself is uploading the firmware. But then it gives you the SDK to access it, right? That's.
No, the SDK, okay, we have to create the SDK to access a custom firmware if we're going to talk directly.
So when I'll explain. When you install the SDK today, it creates a how it's called, a rule in the Linux kernel that when you connect that USB, if it detects it, it goes ahead and upload the firmware.
That's true.
Right,
but
we can change that to a different firmware, which means like we will have our own SDK with it.
Yeah, of course we have there, but
it's just FX.
No, okay, but that's 50% of the equation.
Yes.
50% of the equation, yes. The other 50% you have to create the drivers in Linux to access the ones, the SDK that created in the firmware.
Not really. It just detect the device and run the FX load and upload the firmware. That's it. You don't need more than that.
No, but what will the firmware do? I don't get it. How I get the image from there?
Christian, you can explain it because you've been doing that for years.
Christian?
I guess he's not available.
Christian, can you hear us?
Yeah.
Aren't you kind of talking about building a custom driver essentially? Is that the kind of what you're talking about there? It's just sort of building your own driver, not dealing, because I mean the SDK, I normally think of that as just like the manufacturer supplied, software developer kit that gives you the interface there. But yeah, I guess usually that would rely on having some kind of driver.
Yeah. So the way astronomy camera works is that because and Rich, I mean, I'm really more comfortable if Christian speaks about it because he's the expert on it, not me. I've experienced it very little. Christian, are you available?
The custom firmware basically is some kind of a new SDK. We just have to adjust what is uploaded and in what order. The problem we have is with the Python SDK, it slows it down up to 74%. And if we're using a different language, like let's say Rust, we can speed it up, and therefore we can get much more operational speed. But the main thing is we have to cool it down for the night below minus 25 degrees Celsius. This increases not only the sensitivity and reduces imaging exposure time, but it reduces the noise. It's quite high. Yeah.
Well, it's very difficult to hear you.
Yeah, Christian, you're dropping out.
But Fabio, from what I heard, there is also like some physical things we can do with like.
No, but we can do that. Yeah, we can do that with SDK. That's my point. We don't need the custom firmware for nothing. Just if we want to build anything specific directly on the sensor.
Right.
But and right now we are getting directly the images from in C++ as fast as we can from the USB driver. So it's not a matter of Python or Rust or C++. That's okay. The thing is that, and we don't need the custom firmware. We can upload a custom firmware for us to have specific things directly on the sensor, but we can achieve anything that we need right now just commanding the SDK, and we can get the raw image from there.
For now, that's okay, but for getting some more performance out of it,
we lost.
We lost you, Christian.
No. But my point is, the custom firmware will just write a custom software inside the sensor to run there. But if you're going
to try to get this.
No, right now, what's happening, Fabio? The firmware, the software in the firmware does build all the image and everything. Okay.
Yes.
And we want to get the raw data out. Okay, in anomalies. So like electron count from the sensors. Okay. And then we can rebuild the image whenever we want to later. The image is less important, but the anomalies on the of the electron on the CMOS. Think about it like you get a 2D, right, of an electron field that is running there. That's what we want, and we want to understand the anomalies that it has.
But yeah, okay, but that's I already have that right now. I already access the raw data from the camera right now. If you want the full 12 bits from the image, we can have them, and that's the electron count, in fact, because it has an analog to digital converter that's converting from the analog to a 12-bit digital image sensor data, and we can access this data already. That's we don't need a custom firmware to do that. That's my point.
You have the analog data?
No, have the digital data.
No, so I'm speaking about the analog data because that's what you work with in the firmware.
No, there's no analog data in the firmware. We have an analog to digital conversion, and then we have the digital data. We have no analog data.
Yeah, true. Okay.
Analog data, you don't know the voltages on the individual pixels or anything like that, but I mean, you just get an intensity level off this kind of sensor. So I think what Fabio is saying is that, you have, he has access to that raw data, basically.
Okay.
And that's what we are using right now. We are using the raw data. In fact, not because I command the sensor to do 8-bit instead of 12, so it can get a better speed from the USB, because we also have to download the full 16 bits because it converts 12 to 16 bit and then sends it down the pipeline in USB, and that's slow. But for nighttime, that's okay, because for nighttime we will not be caring much about frames per second. Then we can get the full 12 bits data of raw data and process it. And
okay, not my expertise firmware, but I know it's very common to write custom firmware for astronomy. So I'm trying to understand the reason better.
No, that's okay, because
Christian, sorry, your microphone is giving a lot of noise. Christian, Christian, I'm muting you because your microphone does a lot of noise. Okay.
Okay, and no, that's perfectly fine for us to create a custom firmware in the future, and create our own SDK to access the firmware, because if we're going to replace the custom the current way that the SDK, that the QHY SDK that we are using for our own functions there, then we have to create the drivers for accessing also the firmware. That's my point. So we have 50% is the firmware changes, and the other 50% is creating the drivers. Yeah. So we have to manually program the USB connections and blah blah blah. So and that's a lot of yeah, it was a lot of fun. Yeah, we can say fun. Yeah. It's a huge effort, but I think that's something that will be good for us to do, because right now, even though I'm using the SDK and the SDK provides me a lot of functionality, everything that I can download the raw data and things like this, there are some things in the SDK that I don't like that much, and that if we do access the firmware directly, creating our own drivers, it will be easier. Yeah. But I can wait there. I can wait to do that in the future when we create our own firmware. That's perfectly fine. So, but just for you to understand right now, what I'm getting right now is I can get the raw image, the raw 12-bit analog to digital conversion of the sensor there. Okay. I can get it, and I can manipulate that data as much as we want. Yeah, and that's what I'm doing right now, and a lot of ways.
I guess you get it the 12-bit per channel, and there are 4 channels, right, per pixel.
No, there's only one channel per pixel. Because I don't know.
I mean, there is red, green.
No, there's not. No.
These kind of image sensors just have it's just intensity.
Yeah, that let me explain. There's no red, green, and blue channels. Okay. There's none. There's only one channel, and that's just the pixel intensity.
So that's not the raw data of the CMOS.
No,
it is.
Listen, Idol. No, we only have one channel of data. That's the mono image. Then on top of the sensor, let me look in here. On top of the sensor, we have the sensor. The sensor is mono. It's not a color sensor. There's no color sensor. Unless we're talking about CCS and things like this. The CMOS sensor, it's a mono sensor. It has in front of the sensor, it has a
filter.
A filter, not only they are a biofilter, and each pixel has only one color. So we have the first pixel on the left will be a green, then the other one will be a blue, then a red, then a green, then another green.
Got it. Okay.
So that's it. Each pixel is not a full color pixel. Each pixel is only one color pixel.
Okay,
then
so
we
when
have,
you speak about when you speak about the 12-bit, it's actually per digital analog converter.
Yeah.
yes,
Analog,
that's
analog to digital converter. Sorry.
yeah. And so
Very interesting. Got it.
so what you have is this: we have a mono image that has each pixel has just an intensity, and we know the Bayer pattern. The Bayer pattern can be red, green, green, blue, or blue, green, green, and so with this Bayer pattern, we can convert this mono image to a color image and use it.
Yeah, got it.
So that's how it works. So we don't really have a color image on the sensor. That's not how it works.
Yeah.
May I interrupt here, Fabio? Now,
Sure, of course.
we are talking here a lot about images. So basically, a sensor is not an imager. There is no imager. A sensor is just a collector of photons, and it does it in a certain time until the shutter opens and closes again, and then the amount of charged particle countings are then calculated. And this ranges up to in the millions of photons per, let's say, time, let's say a second, for example, which has to be then normalized towards something that is imaginable, where you can create something that looks like an image. If you have, because RGB goes from 0 to 255 and nothing more. If you have a photon count in an interval from 0 to 2 million, then you have to normalize that and squeeze that down. And I think that's the thing that Ido was talking about, not about the image, to see the sensor as a sensor, not about an imager.
Yes.
See, yeah, but that's I understand that. But the thing is that we don't have this million count, because that's not how it works. Right after the sensor, we have an analog to digital, or in fact everything is digital, but that converts the pixels to the digital value, like you were saying. So that's perfectly fine. So, but that's what we have. We don't have the pixel count. We don't have the 2 million. We cannot have that. We only have
12 bits per one. Yeah, 12 bits per.
So we have a 12 bits. We have a 12-bit amount of data there that goes from 0 to 12 bits is 4,000 and to 4,096.
Yes.
And that's what you have. And we don't have the pixel count or anything like this. We only have from 0 to 4,096. That's what we have after the sensor.
And 0 in black and 496
is completely white. Yes.
Yeah.
That's what we have.
This is only true for that particular firmware running on that sensor. Because I can remember Christian telling me once, and Christian, please correct me if I'm wrong, that with our own firmware, we would be able to have access to the buffer where the photon counts are in.
Yeah, that was my understanding. Yeah.
And circumvent the normalization process.
Yeah. And I think we also can access the voltages numbers and all of that.
Yeah.
Because you're on the chip itself.
I might be completely wrong. Then I will just shut down.
It depends on the type of sensor that we have. But
I think we're speaking about something that we need someone that wrote firmwares before to explain.
Yeah, that's true, because in my research before when I start doing all the SDK and things like this, the research I did it was something with the sensor itself. This sensor only provides 12 bits of data per pixel.
The firmware of the sensor.
Well,
the sensor itself is 16-bit.
No, it's not. The sensor is 12. It's 12, then it's stretched to 16. It's not 16. 16 is that we don't use this 12 bits because it makes no sense to try to align everything in 12 bits. Then so it to be a mess to align then in 12 bits and then to unalign then it to be just computationally expensive.
Yeah.
So what they do is they have the 12 bits data, and they stretch it to 16, and then they send the 16-bit data in 2 bytes. And that's much more computationally better than doing the other way around and trying to pack 12 bits together.
Okay.
Yeah.
Right. I think what he's saying, and which makes sense to me. Again, caveat, new here, but most of these sensors, that I've had experience working with, these kind of like just CMOS sensors or whatever, they're just going to give you a single number at the end, and that number corresponds to something related to the amount of light that the sensor sees. It's not a direct correlation to number of photons, because you need like photon counting detectors to do that, which are different, but it's roughly consistent with that. So you're going to get some number, which I guess in this case is a 12-bit number, per pixel, and that's the total intensity level. I mean, at least that's my experience from these things. So
yeah, and that's this sensor limitation, because I have my other camera here that's a QHY, much simpler. It's not cooled. It's just a 6 megapixel camera, but it goes to 14 bits per pixel, not 12. It has 14 bits per pixel. So it's more a sensor limitation than firmware or anything like this.
Okay, so then you need to convert that to a 16-bit number to make it easier to work with. Stuff, I guess.
That's true.
But now you're already talking about the bit, the sampling rate, and the sampling rate is something that software is doing or electronics is doing. So
electronics is doing,
Yes, but if you via the firmware have access to the raw frame buffer without circumventing
but there is no raw frame buffer. Everything is digital here. We don't have an analog. It's not an analog, because the sensor itself, if you just get the sensor, you only look at the sensor itself, the output of the sensor is analog. It's digital. It's not analog. It already does the analog to digital conversion.
From your point of view, there's no way to circumvent that. That's built in, let's say, electronically, and we cannot even come closer to the sensor.
Unless we strip the sensor and do all the whole logic there.
Like expose the wires or something, but I don't see why that is necessary. You get the number off it. That's the data on the sensor. I mean,
and the frame itself is digital. We cannot access an analog buffer. So it's already a digital buffer. There's no analog buffer. So it's everything's already digital there. If you access the raw buffer of the sensor, it's digital. It's not analog.
Yeah, it has to be digital. Otherwise you can't read it out. It is in the buffer already. So yes.
Yes. So that's my point.
So what it means, and Boyan, you can explain it on the electronic side. What it means is that the digital input on the chip of the sensor, it's 12-bit.
It's 12-bit.
So the matrix that it accesses is a 12-bit matrix.
Yeah, everything is 12-bit until the end. I think, but until you get and manipulate it. Yeah, that's it. So, for instance, we get the 12 bits from the sensor, and then the firmware converts the 12 bits to an 8-bit. And when we want 8 bits instead of 16, it converts to 8-bit, and then it throws down the pipeline with 8-bit because it will be a shorter image, and so you can get a higher frame rate with 8 bits than with 16. But that's it. That's where the firmware comes in. But the raw data is 12 bits. For this sensor, we have other sensors that can go to 14, 13, 15 bits, but this sensor itself is 12 bits.
May I add something to the discussion?
Of course.
Which is, of course, we want to have high FPS. And the only crucial point in the system to work properly is the background subtractor. Does the background subtractor can recognize an event in that data set? In the frame, let's say. Whatever the frame looks like, however it is compressed or sampled or whatever. I think the background subtractor is at the end our benchmark of how good the source frames are generated. So, and I think first of all, is this correct from your point of view? And for second, I think it is, according to IDO, please correct me if I'm wrong here, that at the end it should be a ROS node that can be configured so that the system can reconfigure itself to better values for certain, whatever, daytimes values or whatever, or even find a neural network that finds even a better setup for the camera to make the BGS work more properly.
That's true, and that's how it will work in the end. Right now, it's not. Right now, it's just one configuration. But it's the background subtractor and also the camera and everything will be configurable. And they are configurable already, but they are not configurable by changing parameters on the ROS node. But they will be very soon. We will just have to create the proper feedback loop, and so we can change the parameters accordingly. That's perfect. The thing is with the tracking and the low frame rate is that there's no good tracker that can process an object with low frame rate. Because, for instance, if we are going to track the ISS with a 5 seconds image, it will be just a trail. And then we'll get a trail on the image, and that goes for the background subtractor. It will get that thing, and the next frame it will be here. And that we cannot know that's the same object. It's hard for it to know. So it will not be trackable. It will just be an image.
Of course, but it's intrinsic into the software. We know that when it's nighttime, we know when the exposure goes up and when the FPS goes down. So we know that the point in time when that happens, we can then make a tweak on the BGS to recognize an object, an event at the end of a streak, let's say, and not the streak as itself.
Yeah, it will not be the BGS. The BGS we can.
Or the tracker. Sorry.
What we tracker. Because the BGS itself will be able to adjust it to nighttime. So we increase the threshold, so we get only the changes. It will be okay. The thing will be the tracker.
True.
The tracker will be the most problematic thing because then you have to know that the same object can be here in one frame and then you'll be here in another frame. The second frame it will be or even further apart.
So I have a question. I have a question. If we are receiving the raw data and we are sending it, okay, even in 20 frames per second, okay. Forget about the exposure for a moment. You're just counting, as you said, it's the photon counts or whatever, right? Can I add the cameras, the frames one on top of the other? Can I merge them over time?
You want to do? Okay, yeah, we can do that. Of course, we can do that.
The dark part.
Yeah, we do that a lot in astrophotography. Okay. We stack the frames in astrophotography, and we do that. That's the main thing that we do when shoot astrophotography frames. That we stack everything together, so we reduce the noise and we increase the contrast of the image. We can do that.
So can that be a solution for nighttime?
No, because it will also create trails if you have a moving object. That will be the same problem. We just have a better image in the end. If you want to do that, we will be able to, if you do it properly, we'll be able to see the galaxy. But we'll not be able to track anything.
I would rather question whether streaks are a bad thing.
No.
Yeah, okay. That's right.
But bear in mind that we don't need a high accuracy, perfect image from the Allsky. I'm trying to make it more work like an eye, right? So if that it means it's blurry around the edges and only have high resolution when you focus. That was kind of the initial thought of why we want a specific firmware, right? Because we don't need to read every pixel. We can read important sections, right, and create something that really more works like the eye, right?
No, I didn't get it that much. No.
Well, but you don't know which part's important a priori.
Yeah,
you look at everything too.
Again,
to find stuff that's interesting.
Okay, so you're looking at the sensor like it's working on its own, but if it's parting for a robotic system, then it has a feedback. And that feedback be, okay, this is the stuff that I recognize as the AI as what's important over time, right? And I can do like a initial scan on the sensor and on the metrics. In the end of the day, it's a metrics, right? See what's there, see what object I detect, and then start to be curious. Okay, I want to focus a bit on the right. I want to focus a bit down. I want to focus on that, and that's what I'm starting to read with more, I would say, frame rate, but way smaller, frame than the entire frame, right?
Yeah.
And I can do bits of pieces and decide, okay, I'm curious about 3-4 objects. The rest are less important, so I can read them, these pixels. The deadline for these pixels are less important to me, right? If I think about the ROS2 kind of terms of things.
Yeah, the thing is that we have two things here, Idols. Okay, let me address them. The first thing is that we can do that on software. I mean, it doesn't matter if it's on firmware. Let's forget it's firmware, or let's suppose that we have access to the whole frame buffer of the image, and we can select parts of the image from there.
Okay,
that's okay. But the thing is that that's not how the sensor works. Okay, because the sensor we have to set it to an exposure rate, and we have to set it to mainly the exposure. That's what mostly that matters most. And then it will start getting the pixels from top to down. That's this sensor works like this.
Mm-hmm.
And then we can access the data on the image when it finished that. We cannot I cannot shut down all the other parts of the sensor and just look at this. I cannot do that. And so in the end, it does
like a custom image, of a specific part of the sensor, right? Can't do that. Right.
I can do ignore everything else and just count the pixels on this frame here and give me that. I cannot do that. So in the end, it doesn't matter because it will not speed up anything up because you just speed anything that we want to send on the USB system.
I actually think that's exactly what you can do with the firmware. I think the firmware is, in the end of the day, is how you read everything from the metrics, the electronic metrics that the sensor has. It has to.
Okay, no, I'll say. So that might be.
It has to be software.
That might be the case. I really don't know. So I'm not go deep into this because I'm outside of my comfort zone right now.
That's okay. We'll reach out to Christian and discuss it because I think.
So the question, and then please don't talk besides both of you. You're talking about the same thing. The difference is that Fabio is of the knowledge or of his opinion that there is an electronic of the camera that we cannot circumvent. We only get out from the analog digital converter a 12-bit image, and that's it. That's the image. We cannot come closer to the sensor. Christian told me something different. He means that we can read out or we can tweak the sampling rate or something. I don't know. The thing is, if we cannot we can only take the image as it is from the sensor because the hardware delivers nothing else. And then we can crop it and make a stream which is smaller. But if we cannot circumvent electronics...
True.
And my point is that I don't think we can, but I might be completely wrong here. And so I would love to learn more about that.
Well, what I'm trying to ask, I guess, in a different words, is can we simulate keep the high frame rate and simulate the exposure?
No, that's my opinion because it's like this: you get a whole image and then you can select the places, and then you have a whole image and then select. It's not like selecting the place and then just getting the frame rate here.
Yeah.
No. Forget about that. Asking about what you call stacking the frames. Can I simulate with stacking the frame the exposure of have a better exposure?
Stacking the frames having a better exposure. Yeah, you can do that. Yeah, you can do that. Yeah,
okay,
but it will be in software, but you can do that. Yeah.
Yeah. I'm speaking about software, right?
Yeah. We can. Okay.
So that potentially allows us to keep higher frame rate at night, right? But still, we're using AI, right? Be more sensitive with the light.
Yeah,
that kind of depends, because it could be a situation where you have many fast exposures with low light that you're collecting together and trying to analyze, versus having a longer exposure time, which gives you the streaks or whatever.
Of course, but think about it now that it's a time series problem that I can solve very fast with a far better compute than what the sensor does.
No, yeah, right? we can do that. We'll enter another realm.
Just a second. What it allows me to do, if there is an object that is moving, first of all, detect that it moved, also make it brighter, right? Because I do over time, and then do a simulation of how it looks for every frame.
Simulation.
It's a complex feedback loop, but you can do that.
No, yeah, it will be very complex, not doable right now, because we went on another totally different realm, because we will start having like ghosting.
We cannot do that without the recorder. I know that. We cannot do that without the recorder. But you can have a node today that looks at the last, that always keep in cache the last 20 frames.
No,
and we can just stack them, stack it, and post it. That's what I mean.
Right. Yeah, right now, for instance, I understand. Right now, for instance, I'm just for you to the background detector that we are going to use, the Vibe, it uses 20 frames, the last 20 frames to compare the background. It already does that.
Exactly.
It works like this. But we can do that, but that's we will enter a totally different things with the tracking, and everything will be totally different.
Okay.
The configuration will be totally different
because we are doing it per node now.
Yeah, and what will happen is the image will be blurry, and the object itself will have ghosting, and will have a trail, but that's doable. And it's just another problem that might be good, but it's a problem that we'll have to have access to data to test it for us to really see how to solve the problem.
Exactly.
Yeah,
I think you probably need access to data either way to be able to test these different.
That's true. True.
And isn't stacking something what you can also do with gain, raising the gain?
Yeah, the problem with
that's
gain,
what I'm talking. It's kind of what's better, where you just increase the gain on the sensor and you get a streak over a longer exposure time, or take many short exposures and then try to stack them together or post process them to figure out whether you have a moving object. I mean, that's kind of a computer science image analysis question. That like, which one of those is better? I don't know.
Well, it's where you have compute. That's where you do it.
Right. Sure. Yeah.
So that's the thing. We are already increasing the gain. We are playing for that already. We are doing that already. So, we have a gain limit. So in the case of the sensor is 60.
60.
It's 54 in fact.
54.
But that's the limit of the sensor. But what happens with gain is that the gain is just a multiplier. Okay. And so every time we increase the gain, we increase the noise, and every time we increase the gain, we reduce the dynamic exposure of the image.
Mm-hmm.
So when increasing the gain, we're increasing the light and also the noise.
Mm-hmm.
Okay, and also we'll be reducing the dynamic exposure of the image. So for instance,
stacking does not that.
Stacking, no, because we'll just be stacking images, and we'll have the full dynamic dynamic range of the image.
Okay.
But stacking creates a whole different problem with ghosting and trails and things like this. It's amazing for study images. That's why we do it for astrophotography, because we are shooting the same object, the same galaxy, and like we take
Yeah, but again,
5 minutes exposure, and then 5 minutes, and then 5 minutes, and then we stack everything together to get a better image from there.
Just a second. This is where anomalies come into place, because you have for each pixel, think about it like a weight, okay? And that's how you eliminate the ghosting, because if the weight is positive, and now it comes like let's say black, completely black, right? Then you reduce the weight. So now it has less count in the next. You know what I'm talking about, right?
No,
So
no. I know. I am just talking that we'll create another problem for ourselves. That might be a good problem.
Just a second. The idea is to get like think about it, an histogram of anomalies, right? Yeah.
Yeah, it's just another problem that we have to figure out how to solve it. But I think that's a way to do it. We just have to see how to manage to get the right parameters in the stacking, because we have several types of stacking that we can do. We have tons of different types of stacking that we can do. We can additive. We have like contrast. So we have very different ones.
Yes. Yes.
Yeah.
But that can be a good experiment for someone to take and try.
No, I totally agree.
Right, yeah, if you have the data, yeah, sure.
Yeah, I'm totally with you. I'm totally agree with you. That's perfectly fine. And but that's it. And then so have to. Right now for alpha, we'll not be able to track a lot of stuff at night. We will be able to see images. We'll be able to track. And we'll be able to maybe see trails, but we will not be able to track even the ISS, because it will be just a long exposure.
So if I come back to the question, is a streak something bad? I don't see it as a bad.
No, it's bad for tracking, because
as it is now,
unless
because the tracker now thinks that it needs a certain coordinate and then looks in the next frame to the same second coordinate. But my question is, the tracker could be tweaked towards recognizing a streak, because a streak is a direction already. You have a starting point, and it's a vector. So basically you know per time, and you know the exposure, so you know when it started, when it ends.
Yeah, that's true. But that will work with not very fast objects, okay? And it depends on the exposure that we are talking about.
Yeah.
If we're talking about a 5-second exposure, then when we're finished with the processing of the image for the 5-second exposure, and we try to look at the next image again, the object will have a trail here, and the next trail will be here.
Yeah,
so okay,
like a dashed line. Yeah, exactly.
Yeah, it will be another dashed line. Actually, it's curved because of the lens, but yeah, we can figure out something.
But Fabio, think about it. If I have a sensor that only gives me, because of so high FPS, it only gives me points, real coordinates of an object at a time stamp, and then in the next frame a distinct another point. I only have points, and I have to connect those points in order to get a vector. With a streak, I already have the vector.
No, I got it. You're right on this point, but it will be we'll be using a totally different tracker, a totally different node, a totally different.
I would say
needs enhancement towards this. Yeah.
I would say we should get data of raw images, okay, and like single frames with high FPS, and then
single frames with lower.
Try to do like try to do long exposures, and see if we can simulate that. We'll see if we can simulate that.
Test data, I think, is important.
Yeah. We definitely test data.
I just want to point out that from sort of single molecule microscopy type experiments, there's a pretty rich literature on single particle tracking. Probably I'm not so familiar with the software, but there's probably a lot of libraries that are available for doing this. People who try to track like single fluorescent beads around in cells and stuff. That kind of stuff is out there. So they're just going to say there should be some stuff available.
No, but we're already using.
Okay. Yeah. Fair enough. Yeah.
off-the-shelf trackers to do what is. In the case of cells, it's a little bit easier because it's very visible on the image where the cell is. So we can predict it, and that's fine. In our case, our problem is not the daylight exposure that then we can see the object and then we can track it. Right now it's working. Our problem is at night that we cannot see the object, or if you want to see the object, it's a trail. And that's the problem.
So the question is, can you build a trail using stack images, stack frames?
Yes, but it depends. So it's a it's a compromise. We have to figure out the best parameters for us to have a little bit better frame rate, because even stacking does not solve everything, because if you have a very low exposure time, we will not get almost any data from it, and it will be very, very low.
No, you'll get data from the stack image, right?
Yeah, so I have to stack.
Yeah, I'm not speaking at replacement. I'm thinking about this addition. So think about it like you add that capability to look at the stack images for the tracker, right?
No, that's fine. That we can do that. We can do that
in order to increase the frame rate, right? And that will allow you also to see the vectors, like Richard said, right?
Yeah, true. We can. For instance, we can
it's more data for the tracker. That's all I'm saying.
No, perfect. That's okay. I can build a node in a couple less than I can build a node in a couple of days that stacks the image and displays the stack of the image. That's fine. That's not hard, because I just have the image. I just have to add them together.
Yeah.
So
we just have to. It's not just two. It's like you need to look at that multiple slice time. Let's say, and we pick, right, and those are like ROS2 configurable, right?
No, true, right. I'm just saying that I can stack as many nodes, as many images as you can, and create a new one. That's doable, but I don't think that. Yeah, I don't know. Anyway, at least now we have.
Once we have a recorder, and the recorder is more important, that's something that we can experiment with.
Yeah, true.
Right, and see if is there something there or not.
No, true.
Right, I think recorder after alpha recorder is the most important thing.
I had kind of a bigger picture question. Is it important to do real-time tracking of this, or is it possible to simply have a system that has enough resolution to capture objects of interest, and then tracking is done sort of offline or later on?
Real time,
for instance.
Can I ask? Yeah. Let me answer that in two things. Okay. First of all, we'll be doing that in real time for two reasons. First of all, because a real-time system will be able to talk between the station will talk between themselves, and so be able to do a triangulation to get the position of the object. And so we have to do that on real time. And the second is that in the future, not for the alpha, but for the future, for the bigger picture, we're also having a PTF camera. So it's a telescope that will be pointing towards the object that's an anomalous object. And for this to work, we have to have a real-time system working to tracking the object, and so the camera can point it to it, and we'll be also having two different sorts of images, one from the Allsky camera and the other one from the PTF camera. So we'll be able.
Got it. That makes sense.
Yeah. So that's the most the reasons why we are aiming for real-time object tracking.
And
we'll be able to. Okay.
Go ahead, Fabio.
No, we'll also be able to, with all the data that we have, process this data later anywhere, because we'll be recording everything.
Yeah. Okay.
We'll be able to do this, but we also our interest is mainly on the real time, because we wanted to get as much information as we can from the real time. So we'll be able to use passive radar and also the images and the Allsky images and everything, every sensor that we can put there. So we'll be able to try to understand better what we are seeing.
Yeah, sure. Yeah.
And not, I want to add another reason, which is basically we split sensors into, let's say, master and slave sensors. So master sensors are the 24/7 sensors that always run. And let's say slave sensors or secondary sensors are the ones that only are active when there is something recognized, because they would otherwise produce too much data. Like, say, a passive radar dish, for example. If you direct an antenna with a dish towards an object, you want to do this just in the time when a passive radar system that is hemispherically sensible recognizes something. Then you want to steer another one to, like the PDF. The PDF comes in action when there's something seen on the fisheye and not before.
Okay, that makes sense. Yeah.
Hey, a last question I have to Fabio. Yeah, go ahead, Mason. Another question?
Oh, thank you. Yeah, just more extensions from that. And, is there any thought of doing like spectroscopic analysis? I mean, I've been watching that Secrets of Skinwalker Ranch show a little bit recently. And one thing that occurred to me is, with putting a spectrometer, to actually analyze this light. And this would definitely be something where you need to track it, have the, sensor directly aligned with it and everything, focus onto a fiber optic. But in principle, it should be possible. I don't know if that's something you guys are thinking of, or...
Absolutely, yes. We have spoken about this, but this is certainly a topic for the scope that is then directed to an event. It does not make sense to have a spectroscopy.
Exactly.
A big, you would need a big array for a fisheye, a hemispheric scan. But you can do it with a focus. So the thing is that the pan tilt head is then directed towards an event, and whatever we build on that rig will then produce information about where it's pointing to. So of course there will be a camera, because we want to have the close-up videos, of course. But there will also be other sensors like a spectral array. It just takes a little snapshot and then can analyze that and so on.
Yeah. Okay, thanks.
But this is also true for, let's say, a thermal. So a bolometer, mostly bolometers are very low resolution devices. That to use in a fisheye, no. But on something that is very narrow in an angular resolution, in angular field of view, let's say, those things make sense, definitely.
Yeah. Okay.
Hey, Fabio, I have another question. You mentioned that you're working on several ROS nodes that you're now creating, and one of this is the almost famous annotated frame provider.
I'm not working on this right now. I'm working on all the others. Before the annotated frame provider.
Before, okay.
Yeah, before the annotated.
But just I understand the annotated frame provider as what Mike did at the very beginning, to create an output where there are tracks that are annotated, let's say with an ID, with timing and so forth. Do we really need this in the future? I mean, we need the information about, the vectors and the timing, but do we need an image where such information is overlaid and rendered into the image?
Okay. The short answer is no.
Okay, thank you. That was enough.
No. So the short answer is no, because all the annotated frame provider does is subscribe to a lot of different topics and put them together in an image for us to see. That's it. So it
does more than that. It synchronizes the time.
Of course. Sorry,
okay,
I should have it.
It gives us a stamp. Okay, so it's not going to be used the same way, but we are still going to use the node to stamp the frame and make the data authentic. Okay.
Yeah, that's true. That's why I start with no, and then and then yes.
But it's not going to be on the real time. It's not going to be on the real time side, because that's less important for the real time.
Yes, true. So the short answer is no, because we can't do that anywhere else. We can do that on the client. We can do that on it doesn't matter. But the other part of the answer is that if you want to do that on the client, then it will be a little bit harder because it will be streaming a lot of different data to the client, maybe to the internet and things like this. So that's a little bit harder. Doing that directly in the ROS, that we can synchronize the data and then just create a frame that's for us to use on the, for instance, on the client to see already the tracking and the things moving with the data.
But isn't
that's
this
easier?
But isn't this a task that the front end shall do, to paint the rectangles over and to move it over
the front end? The front end can do that. We can stream the data to the front end. And we already do.
Yeah.
We just have to subscribe, and then we have to do a time synchronization on the frames and everything. We can do that on. So the short answer is no, but it's nice. It's just nice for us to choose.
It's nice for what? For what reason? I just don't get it. Since a year, I'm thinking about it. Why?
I can probably help there, to be fair.
Thanks, Mike.
So, no, it's fine. So, initially, it was just an example of assembling all the information for display.
Yeah.
That's it, right? So all, as Fabio says, it just subscribes to a lot of topics and basically presents a visual of all that stuff. That's all it does. Mm-hmm. And in the past, I think when having a view into Sky 360 from OpenMCT, it was just easier to consume or subscribe to the annotated frame provider as a proof of concept than trying to duplicate what it was doing on a web front end.
But we have to do a lot on the web front end anyways. So there's not only the annotated frame rectangles.
Yeah.
No, the annotation.
Yeah, that's fine. So it's really easy. So it can be replaced. It's there just as an example of what if that wasn't there, then I would never have been able to demo anything to you guys with a visual. You know what I mean? So
you need it for development, basically.
Yeah. It's just an example of how to. It was the first example I did of how to subscribe to multiple messages and using like the synchronization ability in ROS2 to ensure that all the messages come from the same source and combine all that data onto a frame. So that's all it is. It's very inefficient, and because there's lots of loops and all sorts of things, and which are written in Python, and it's not multi-threaded and all these sorts of things. But it just serves as an example.
Yes, I get it. It was important. It is maybe still important. But in the future, if we have a user interface, this user interface has so many data that has to render on the same canvas, that it's not only rectangles with timestamps. It's probability from kinematics, probability from image recognition. Maybe we have weather data, we have ADS-B data. So there's a lot we have to still paint on that canvas. That only the frames, to have that already in, is for me a smaller pro than to have a user interface that can do at the end can overpaint everything.
Yeah, it was also. I mean, initially it was to try and we didn't. So it was sort of towards. It was sort of towards the end of like February, I think, or even beginning March, that we figured out how the whole ROS bridge stuff worked, so that we could actually subscribe to this stuff from a web front end. You know what I mean? So, and then there's lots of like disciplines here as well. So I was sort of, I'm not really that good with sort of the web side of things and doing all that canvassy stuff on a web page. But if someone else can do that, then it's a better environment or discipline for them to do that in versus Python. It was just purely a starting point, really,
Yeah.
to try and display the data. But you're right. There's going to be lots of other data that needs to be rendered somehow. But yeah, this was just an example of. It was just the first go at something that you guys could see.
Yeah, no, I
Oh,
we totally understand this. I was only
Yeah,
confused
that's what it was.
that Fabio is bringing it up again today. I was just confused why now.
No, that's not it. It's just as Mike was saying, and the whole simple tracker is just an amazing piece of software that Mike did. And what I'm doing right now is just converting them to C++. And but it's everything that's there. That's amazing piece of software, including the annotated frame provider. And that's very useful for me to see, instead of also having to start the web server and then connecting to it, and then also I still use it to test all the sequentiation that we're doing right now.
A great tool for development.
But that's what we're saying, that's no, we don't need it.
Okay.
But it's just something that's for me right now. It's still useful.
It's nice to have. Yes, get it.
It's still useful.
I'm just going to mention on the subject of web front ends. I don't know if you guys are familiar with this tool Node-RED, which is a Node.js based IoT framework, and I've done a lot of work with that to develop data acquisition systems, and that presents these really nice sort of user facing dashboards you can get, which it's all web based. It runs off a web server on the computer that you're running it. It's good for communication with a lot of stuff, and so it might be something to consider. I don't know. It's not going to solve. Doesn't do a lot with like image manipulation. You're going to need something else to probably do that. But as far as like, putting together the dashboard, presenting everything, doing some basic processing of information, it's good for that.
I'll speak more about that. We looked at a bunch of frameworks, what to use several months ago. And then one of our members actually, she found OpenMCT. We looked into that. And from, if you think about the station as a mission control system, then OpenMCT gives me the best way of how to build one, that is being used. Even NASA uses that to observe the skies. And what I mean by that, it gives me all the mechanical aspects of displaying data and also really go back in time and analyze it. And I spoke about it before, but the playback capabilities, that's what's important. And building that, it's difficult. And if already someone did that, I rather use it.
Oh yeah, I wasn't aware of this. Yeah, this looks pretty cool.
Yeah.
And I guess it had good sort of playback capabilities.
Yeah, they actually did a large kind of shift and moved it to Vue, and Vue is pretty good and have really good performance. And again, they are using to display everything from what the sensor they have. And again, it synchronizes all the panels with the same time. You have that capability, and that's really, really important for us.
Cool. Yeah. Cool. Thanks.
Just one last update from me is that since now we have at least Aussie Joe from Australia with the camera outside, I'll be modifying the camera app a little bit to save, to record the still images and on the full resolution with all the data that we got from the camera, so we can use it to gather data and to try to process it later. Right now it was not doing that because it was not meant to do that. But since right now we are seeing that we need it, I will be adding a couple more functionality to the camera app to save still images, full resolution still images, and also a couple things more.
So you can use ROS bag to actually record for now.
Yeah, right now I'm talking about the app. The app is not built on ROS. It's just that app that you have that you to.
Got it. Okay.
And just talking about it, I'll just mention I'll mention again that we did last week, that people are still confused about the apps, the Sky 360 software.
Yeah.
So we need a way to direct people to somewhere for them to understand what state that we are, and what is the features of each of the things that we have. The camera app is just, as I explained on the channel there on dev support, it's just an app I did to display the image of the camera and also to help focus, and it does a lot of things more, but it's not a monitoring system. It's not the Sky 360 software. And I received this question a lot.
Why don't you retire it?
It's still needed for development reasons, isn't it?
Yeah, that's it. Yeah.
So again, for the development, it's fine. But do we want now to support development apps? Because I know it puts a lot of constraints on you.
No, I know. I'm not doing. Let me answer. I've just the phone here just now.
Yeah.
Okay. So Ido, just in a short second before we go on, I think Yannick left us, so we cannot talk about the Science Advisory Board.
Yeah.
I can give you a quick rundown what the idea is and where we are heading to.
No, so let's start with it next week.
Okay, great. And Lionel is... Lionel?
I think you just disconnected accidentally.
Yeah, really? I was just saying, Lionel was at the conference last week, and I wanted to get feedback from him, so what went on and what his impression was and so forth. Naja, anyhow, maybe he can enlighten us next week.
Well, Lionel had to go. Yeah, I just see.
He typed, okay.
Sorry. So no, what I'm saying is not. I'm not giving support to the app. I was just helping present, for instance, some of our developers to make it work. But
got it.
But that's it, and to make it work and for them to display the image from. If we didn't have it, we would not be able to see the image for Nozi, for instance, and to test the everything that we're testing right now.
Yeah.
And that's it. And it was also a very useful development tool for myself. So I could build the SDK, the QHO SDK, and a wrapper around it, so we can use it on ROS. If I didn't have it, I would not be able to see anything on the QHO camera right now, even in ROS.
Yeah.
And that's it. But I just think that we need somewhere very specific explaining the current status and I don't know, because I've been keeping asking to add things there and I would not be able to, and it makes no sense because it's not the Sky 360 software that it will be run on the station. It's just an app that you'll be able to that we will use it to help focus when we're building the station. It will help you focus the lens, and it will help you do a lot of things. But that's
so the question I have: why we don't build this in ROS? Because we will need to do it anyway.
It's a little bit trickier. I will explain it later, but yeah, in the end we can do that. But we'll have to synchronize that also with building the UI for this. Okay.
Exactly. Now you see, like I'm breaking the apps, the single app into like modulars. Yeah.
Not true. I already talked to Dan about it, because some of the things, for instance, selecting the field of view of the camera. You'll be able to do that. You'll be able to do that in the UI. Right now, I do that on the camera, on the app, but we'll be able to do that but that's something that you have to build it. Right now, we already have it on the app, so we can postpone it for later.
No, so what I think, you can pause the development of the app, okay, and then decides what's your priority, importing stuff from the app or putting some new capabilities on ROS.
No, right? True. But the thing is that right now we needed a couple of more things in the app. For instance, the screenshots and things like this, just for us to try to analyze the data and see how we can do the night shots properly, at least for now.
So I will argue, okay, that you need to put a stop and not do recording like that, because that can go to a different direction. And I rather focus on having ROS2, because once you have everything in ROS2, just a second, improvements on that is going to be fairly easy. Compared to right now, you're adding more features and improvement on an app that is not aligned with where we want to be.
No. Okay, I got your point. But what I'm going to do is just write something that takes like 5 lines of code. It's just getting the image and saving the screenshot.
Okay, got it.
And that's it. It's just I'm not adding features.
I understand. It's comfortable for you. I get that.
No. It's just I already have the image. What I'm going to do is just image.save and then saving the image and just adding a button on there. And that will be useful for me, because right now I need it to test the auto exposure algorithm.
Got it. Okay.
I needed to test the auto exposure algorithm and to see the full image, because I need to see the full image and also to analyze the data so I can see if I can stretch it. If I can stretch the
No, I get that.
Okay, perfect.
I'm just like pushing for.
I know. But anyway, if you can look at the repository, ROS2 repository in Sky 360 that I'm building. I'm doing a lot of work there.
Oh yes. So
thank you.
I know. Actually, I'm totally on your side, because I only want to see it happen yesterday than tomorrow.
Yeah, me too.
But it's only we have so little time. But
no,
I think
I think that's we are actually really bad at, when we are so tentative, to input from people and questions, that we not focus on the direction we want to take it, and that's my concern.
Okay. Yeah, there was a little thing that Fabio is now doing, adding some couple of more lines to this, but I think he's not doing a big thing out of it. What I heard from Fabio when he started today, he said that he is now converting all these functions and libraries into C++ to speed them up. I think that's the point when we have
and to
ROS2, right? That we have those ROS2 nodes in place and running.
Yeah.
And then comes the UI. Nothing else. Recording, yes, but later.
So UI. With all honesty, Fabio, if you're less comfortable on web, on OpenMCT, and you want to continue with the app can listen to ROS messages.
No. I'm not going to continue on the app. The app something that I
you understand what I mean?
No, I do, but the purpose of the app is completely different from the ROS2. It's just an executable that you can run to get the image from the camera. That's it. So we can look at the image from the camera, and also I was testing a couple of algorithms there. I used it to test the background subtractor properly.
But that's exactly the purpose of ROS also, to allow you to test everything.
I know, but we were not able to do anything if I didn't build that before.
I know it's an evolution, but I'm trying to push you the time, to do this stuff in ROS2. Like, we need to start.
No, it's already started. I'm doing that.
Cool. Yeah, cool.
But right now I'm almost alone doing that, and so it's I know it's a little bit of pressure because I still have my full-time job and I still have a lot of things to do.
Yeah. Don't worry.
Oh, you have family too. Oh.
And I have family, and I have Julia that's only 2 months old. So
Yeah.
No, please, Fabio, don't get either wrong here, okay? We're not putting any
no, I
pressure on
don't.
anyone.
No. I do as a friend.
Yeah.
I'm totally
we
fine
are
with that.
really good friends. So he knows where I'm coming from.
Yeah, he's just
Yeah.
pushing, and it's his job to push. That's okay.
Yeah.
All right.
No, I really don't like the fact that you kept getting distracted with, the small features on the app. And I know how much you want to do the conversion to C++. So I want to try to help you do that. That's the.
I'm doing that. I already put aside. I don't know how many hundreds of lines of code on the conversion. So.
Yeah.
Okay, Ido, can you update us? Yeah.
Yeah, go ahead.
Can you update us on the NixOS front? Is there any update? Any news?
No, honestly.
Okay.
I'm waiting for a new laptop to work on.
Okay.
It will be just more comfortable for me with the new place. So we'll be doing that, but as you know, I'm working on the other stuff that I can't really speak about yet, and that takes a lot of my time. And I have an update for you, Richard, that I think you will like.
Okay, we do it afterwards.
Yeah.
Is there anything else we are talking today on record? Okay, then I would say we wrap it up and close it down for today.